Let's start off with third chapter. So trigonometric functions. We have learned in 10th class 10 about trigonometric ratios. What is trigonometry? That is, it's nothing but the measurement of the study of its angles and sides. So over here you are having, what is this in exercise 3.1? Find the radian measures corresponding to the following degree measures. So you know that every unit, without units there is no measurement, we know that. So even angles have measurements. So what are the two measurements which angles have? We'll just see. So before going into the problem, I'll just tell you, give a briefing about what are the two measures. One is degree measure and the other one is, second one is radian measure. Most of you have heard about what is degree measure, but radian measure is new to you all. So what is radian measure also we'll see, what is degree measure also we'll see in terms of radian, and radians in terms of degree, how to write it down we'll just see over here. So here you have one rotation is equal to 360 degrees. You know that if you are having a point and this complete rotation is nothing but equal to 360 degrees. We have learnt about angles over here. So that is 1 degree is equal to 1 by 360th of one rotation. Isn't it? This only I have written in this terms. Now when you are taking a clock, you know that in a clock that 1 hour is equal to 60 minutes, and you also know that 1 minute is equal to 60 seconds. So now here we have 1 degree is equal to nothing but it's equal to 60 minutes. That means it is taking one complete rotation. The bigger hand of the clock, when it's going complete 360 degrees rotation, it is equal to 1 degree. So now this is equal to, this 60 minutes can be written in this way. It is nothing but it's written in this way. This 1 dash over the 60 is nothing but it is minutes notation. Then 1 minute is equal to 60 seconds. 60 seconds means this double dash is nothing but it is about seconds. So now here, how do we write the radian measure in terms of degree measure? We'll just see. So radian measure is what we'll just see here. Radian measure. Now we know that this is an angle. This is theta, and this is called the length, arc length. Isn't it? And this is the radius which we are having. So therefore theta is equal to L by R, where L is nothing but the arc length and R is the radius of the circle. So now how to write this in terms of one rotation, we'll just see. You know that one rotation is equal to nothing but the circumference of the circle, and circumference of the circle is nothing but it is equal to what? It is equal to 2 pi r, isn't it? So now this complete rotation is equal to 2 pi r. So therefore theta is equal to L by R. We having this formula. So that is L is nothing but the length of the arc. That is when it's completing a complete rotation, this angle over here, it is nothing but 2 pi r. So the length of the arc will become completely 2 pi r by r. So therefore this is equal to 2 pi. So that is theta is equal to one complete rotation. We have already seen that it is equal to 360 degrees. So we got 2 pi is equal to 360 degrees. This is the relation between radian and degree. Radian and degree. That means whenever we have to write it in, what is the formula, we'll just see. That is 360 degrees is equal to 2 pi, means we have the formula, degree, relation between radian and degree. Formula, what is that? We'll just see. The formula is radian measure is equal to pi by, here you are having 2 pi by, this is equal, radian measure is equal to 2 pi by 360 into degree measure, which is equal to 2 180s are. So therefore pi by 180 into degree measure. Or we have degree measure is equal to 180 by pi into radian measure. So now we'll go into the first problem of our exercise. What is the first problem of our exercise? We'll just see here. Here you can see what is the first exercise problem here, 3.1. So we'll start off with 3.1. What is the first problem? Find the radian measures corresponding to the following degree measures. So now we have just now seen the formula. This is the formula which we are having. So which formula we have to use here is this radian measure is equal to, because we have to find the radian measure. So we'll be using this formula, radian measure into degree measure. So the first one, solution for the first problem here is, first problem which is given to us is here, it is equal to 25 degrees is given. So for 25 degrees, what is it? We'll see. 25 degrees, you know that the formula here is equal to radian measure is equal to, so wherever the degree measure is there, this is degree measure which is given to us. So we can write here the radian measure is equal to, therefore 25 degrees is equal to, you can write it as, the formula which we are using here is pi by 180 into 25. So which is equal to 5 5s are here, you will get. So 5 pi by 5 3s are 15, 5 6 are 30. So 5 pi by 36 radian you are getting. This is the answer for that. That is 25 degrees is equal to 5 pi by 36 radian. Now what is the second one? We'll see. Second one is given as minus 47 degrees 30 minutes. So it is equal to minus 47 degrees 30 minutes. You know that 1 degree is equal to 60 minutes, isn't it? So first we have to convert this 30 minutes into degrees. We know that 1 degree is equal to 60 minutes. Or you also have 1 minute is equal to 1 by 60 degrees, isn't it? So therefore 30 minutes is equal to, from this you can take 30 minutes is equal to 30 by 60 degrees. So therefore it is equal to 1 by 2, half degree. 30 minutes is equal to nothing but half degree. So you can write this as minus 47 1 by 2 degree, isn't it? So when you write this, what do you get over here? This is nothing but equal to minus 95 by 2 degrees. You can write it in this way. So therefore you have to convert this into radian measure corresponding to the following. We have to find out what is the radian measure. So therefore this is nothing but equal to, again using the same formula, you are having minus 95 by 2 degree is equal to pi by 180 into minus 95 by 2. This is into radians we are converting. So this is equal to, you are going to get here, this is 5 1s are, 5 9s are, again here 5 3s are, 6 are. So you are getting minus 19 pi divided by 72 radian. So therefore you are having minus 47 degrees 30 minutes is equal to minus 19 pi by 72 radian. So here you got this radian, that 25 degrees is equal to 5 pi by 36. Whenever it is positive, you write it as positive radian, and here it is negative, so therefore you are writing it as negative radian. The next third one, what's the third problem which we are having here? The third one is 240 degrees. So now 240 degrees is equal to, you can write this as equal to pi by 180 into 240 radians. So therefore this will get cancelled. So you're getting here 6 4s are 6 3s are, so 4 pi by 3 radian. 240 degrees is equal to 4 by pi by 3 radian. Then the fourth one you're having, what is the fourth problem which we're having here? It is equal to 520. So 520 degrees is equal to, you can write this as equal to pi by 180 into 520. So which is equal to, here you're going to get it 226 are, 2 9s are, so which is equal to 26 pi by 9. So therefore this is the radian which we got here. So second problem, we are having the second problem. Find the degree measures corresponding to the following radian measures. Use pi is equal to 22 by 7. We are going to use here pi is equal to 22 by 7. So what is the answer we get? We'll just check it out over here. So the first one which is given is 11 by 16 is given over here. So now here how to convert this degree, we have to find the degree measure. From radian to we are converting to degree measure. So in this solution, which formula do we use? You can remember only one formula which is easy for you, so that you can understand what is the formula. In the previous problem also you have seen, here you can see that here the formulas, there are two formulas, that is radian measure to degree, that is what is the radian measure given the degree, and what is the degree measure given the radian. You can use the second formula, this one here. So therefore this is the degree measure which is equal to 180 by pi into radian measure. So going into the second one, find the degree measures corresponding to the following radian measures. Use pi is equal to 22 by 7. First one is 11 by 16 we are having. So we are given the degree measures. Now we have to find out corresponding to the following radian measures. The radian measures are given. We have to find out in terms of degrees what is it equal to. So over here we are getting this equal to, we know that what is the formula which we use? Degree measure is equal to (180 by pi) into radian measure. So the radian measure which is given to us here is 180 into 11 by 16 by pi over here. We are given this. So here you are having 4 4s are 16, 4 4s are 16, 4 5s are 20. So you are having this as 45 into 11 divided by 22 into 4 into 7 we are having here. So 11 ones are, 11 2s are. So you are getting here, it is equal to 315 by 8. This is the value which we are getting, 315 by 8 degree. So which is equal to 315 by 8 can be written as, we are getting 315 divided by 8 is equal to 8 3s are 24. So you are getting here 75. 75 means you are getting 8 9s are 9 8s are 72. So you are getting here 3. So this is equal to 39 3 by 8 degree. Now this, you are converting this 1 degree into minutes over here. So you can write this as 39 plus 3 by 8, which can also be written as, here 1 is there, isn't it? So 1 degree is equal to 60 minutes we can write. Since 1 degree, therefore 39 plus 3 into 60 divided by 8. So which is equal to 39 plus 180 by 8. So when you are dividing this 180 by 8, what are you getting here? 8 2s are 16. So you're getting here again 8 2s are 16. You're getting 4 over here. So it is equal to 39 plus 22 minutes plus 4 by 8, which is nothing but equal to, this is all in minutes, so therefore this is equal to 39 degrees. These are all degrees we got the answer here. So therefore we are converting this fraction part into degrees. So this is equal to 39 degrees plus 22 minutes plus half minute, and you know that half minute is equal to 39 degrees plus 22 minutes plus 1 by 2 minutes. Now this we can write in terms of, because you know that 1 minute is equal to 60 seconds, therefore half minute will be equal to 30 seconds. So therefore you can write this as 39 degrees 22 minutes 30 seconds. This is the answer for the first one. Now what is the second? It is equal to minus 4 radian is equal to, so here also having 11 by, this is 11 by 16 radian is equal to, in terms of degrees we were writing that, so this is equal to what we got that answer. So here now minus 4 radian is equal to, you're getting it as 180 by 4 pi into minus 4, in degrees we are going to get the answer for this. So this is equal to 180 by 22 by 7, means over here it goes into minus 4. So this is all in degrees. So therefore now you can write this as equal to, minus 180 into 7 into minus 4 is 180 into minus 28 divided by 22, which is equal to, you can write this as 11, 2 11s are 2 90s are, so which is equal to, you are getting it as equal to minus 229 1 by 11 degree. Now we have to convert this 1 by 11, so we can write this as minus 229 plus 1 by 11, which can be written as minus 229 plus 1 into, this can be written as 1 degree divided by 11, since we know that 1 degree is equal to 60 minutes, so we can write this as 1 into 60 by 11 minutes, so which is equal to minus 229 plus 60 by 11. So when we are writing 60 by 11, we can write it as 11 5s are 55, so remainder is again 5, so therefore you get it as equal to minus 229 plus 5 minutes plus 5 by 11, again minutes over here, this minutes again we convert it into seconds, since over here you know that 1 degree is equal to 60 minutes, and here this is equal to, so you're getting here minus, which is equal to minus 229 plus 5 minutes plus this, if you have to convert it into seconds, you know that 1 minute is equal to 60, so you'll get it as 5 into 1 minute is equal to 60 seconds, isn't it? So 5 by 11 minutes is equal to 5 by 11 into 60, so you're getting it as 11 2s are 22, 8 11 7s are 77, we're getting a remainder of 3, so we can take it as 27 seconds. So the answer is minus 229 degrees 5 minutes 27 seconds. Then going into the third one, 5 pi by 3. Now going to the third bit in second question. Third bit solution is 5 pi by 3 radians. What is this equal to? We'll see. It is equal to 180 by pi into 5 pi by 3. have any fractional part, so we no need to convert it into minutes and seconds. So directly here 5 pi by 3 radians is equal to 300 degrees. Next, fourth one, what is the fourth one which we are having? Fourth one is equal to 7 pi by 6. So 7 pi by 6 means you can write this radians. This is equal to 180 by pi into the radian measure, that is 7 pi by 6. So pi will get cancelled. Here again 6 3s are 6 into 30 is equal to 180. So you are getting here 210 degrees. So this is the answer for your second question. Now going into the third one. What's the third question? We'll see. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? So now here you can see in the solution part we have one complete rotation is equal to one revolution also you can take, so which is equal to 360 degrees. So number of revolutions made by the wheel in 1 minute. Number of revolutions made by the wheel in 1 minute is equal to 360 revolutions. Now therefore number of revolutions made by the wheel in 1 second is equal to number of revolutions made by the wheel, because we have to find out through how many radians does it turn in 1 second. So number of revolutions made by the wheel in 1 second is equal to 360 by 60, because you know that 1 minute is equal to 60 seconds. So therefore here you can see that this is equal to 6 you're getting. So now therefore in one complete revolution the wheel turns an angle of 2 pi radians. So you know that in one complete revolution the wheel turns an angle of 2 pi radian, because we have already seen that it is equal to 360 degrees means it's nothing but equal to 2 pi radians. So hence in 6 complete revolutions the wheel turns an angle of 6 into 2 pi, which is equal to 12 pi radians. So therefore in 1 second the wheel turns an angle of 12 pi radians is the answer. So now in the fourth question, find the degree measure of the angle subtended at the center of a circle of radius 100 centimeters by an arc of length 22 centimeters. Use pi is equal to 22 by 7. So over here the solution. So you consider a circle of radius r units, and this is called the length of the arc from here to here. This is L. So theta is equal to here the arc length L units subtends an angle theta radian at the center. So this is this arc of length L subtends an angle of theta at the center. So therefore you are having theta is equal to L by R, where L is the length of the arc and R is the radius of the circle. So therefore here it is given, therefore from the problem you are having radius is equal to R is equal to 100 centimeters is given, and here L is equal to the length of the arc is equal to 22 centimeters is given over here. So we have to find out what is theta. So theta is equal to 22 by 100 radian. So if we have to convert this into degree, we have to multiply into 180 by pi into 22 by 100. This is the degree form which we got. This is radians converting into degree. So this is equal to, this 0 will get cancelled here, 0 will get cancelled here, 2 11s are, 2 5s are. So you are getting here 126 by, now you can convert this into, pi is written as 22 by 7 means 18 into 11 divided by 22 into 7 into 5. So you are getting here 11 ones are, 11 twos are. So 17 into 18 is 126 by 10 degrees this is. So now if you convert this into minutes and seconds, you are going to get this as equal to, if you are dividing it, you are getting it as 12, 3 by 6 degrees. So 3 by 6 is nothing but here you are getting 1 degree is equal to, you know that it is equal to 12 and a half here. I'm sorry, 3 by 5 this is. So you are getting it as 12. So when you are dividing this, 3 by 1 degree is equal to 60 minutes you are getting. So therefore this is 3 by 5 degree is equal to how many minutes, means you have to multiply this into, so you are going to get it as 60 into 3 by 5. So 5 ones are 5 twos are, which is equal to 36 minutes. So therefore this is equal to 12. This is 3 by 5, so which is equal to degree. So we are converting it into minutes. So 12 degrees 36 minutes is the answer here. This is in degrees we are getting. This is a whole number. This fraction we have to convert it into whole number. So which we are converting it into minutes. So therefore the required angle is, therefore the required angle theta is equal to 12 degrees 36 minutes. Next. So now going into the sixth one. If in two circles the arc of the same length subtends angle 60 degrees and 75 degrees at the center, find the ratio of their radii. So now it's given that let the radii of solution part, what we'll do is let the radii, we have to find out the radii, isn't it? So let the radii of the two circles be, let the radii of the two circles be R1 and R2. So length of the arc L subtend an angle of 60 degrees at the center of the circle of radius 1. So here you can take that let an arc of length L subtend an angle of 60 degrees at the center of the circle of radius R1, and also let an arc of length L subtend an angle of 75 degrees at the center of the circle of radius R2. Let an arc of length L subtend an angle of 75 degrees at the center of the circle of radius r2. So now we are given that 60 degrees, that is theta L by r, which implies that theta means 60 degrees is equal to pi by 3 radian is given. That is, we can write it as 60 degrees is equal to pi by 3 radian, and 75 degrees, how can we write it as 60 degrees? Now you know 60 degrees can be written as pi by 3 radian, and 75 degrees can be written as 5 pi by 12 radian. So therefore we know that in a circle of radius r units, if an arc of length L subtends an angle of theta at the center, then theta is equal to, we know that theta is equal to L by r. So which is equal to, which implies L is equal to r into theta, or therefore L is equal to r1 into pi by 3, and also L is equal to r2 into 5 pi by 12. So we can equate these this 1 and 2, because both are equal to L. They are having the same arc length. So therefore this is r1 pi by 3 is equal to r2 5 pi by 12. Since you can see in the question here, arcs of the same length, both the arcs are of the same length, they subtend angle 60 degrees and 75 degrees at the center. So therefore since both have length of L, arc length is L, so therefore r1 pi by 3 is equal to r2 into 5 pi by 12. So you can cancel out pi here, 3 1s are 3 4s are, so you are getting here the ratio of this, here you are getting r1 is equal to r2 into 5 by 4, or which implies r1 by r2 is equal to 5 by 4. Therefore the ratio of the radii is equal to 5:4. This is the ratio. So seventh problem, find the angle in radian through which a pendulum swings if its length is 75 centimeters and the tip describes an arc of length 10 centimeters, 15 centimeters and 21 centimeters. So now here you know that in a circle of radius r units, if an arc of length L unit subtends an angle of, suppose you're having a circle here, this is a circle, this is the center, you're having this as the radius, and this is the angle which is subtended by the arc of length L over here at the center. So therefore you're having theta is equal to L by r. It is given that r is equal to 75 centimeters. From the problem you can see very clearly that the length, if its length is 75 centimeters and the tip describes an arc of length 10 centimeters. So L is equal to 10 centimeters over here is given. So now in the first bit you get that theta is equal to L by r, which is equal to 10 by 75, which is equal to 2 by 15 radian. Next, the second one you are given here, L is equal to how much? 15 centimeters. So therefore you are having, and radius will always remain the same, so r is equal to 75 centimeters. Theta is equal to L by r, which is equal to 15 by 75, which is equal to 1 by 5 radian. Then next, third bit, what is the third one which we have? Third one is 21 centimeters. Here L is equal to 21 centimeters, R is equal to 75 centimeters. So theta is equal to L by R, which is equal to 21 by 75, which is equal to 7 by 5. You can take it as 3 sevens are 3. 3 5s are 15. 3 2s are 6. 3 5s are 15. So 7 by 25 radian. This is the answer for the 7th third bit.